So, yesterday's lesson was about right angle triangles and solving right angle triangles using Pythagorean theorem and SOHCAHTOA. Today we're going to look at what if I don't have a right angle triangle? What do I use and when can I use these formulas? So there's two formulas that you use or two laws that you can use when you don't have a right angle triangle. And the laws are called sine law and cosine law. Okay? So two different laws that you can use. There is situations where you can use only the sine law, and there are situations where you can only use the cosine law. Okay? We are going to have to figure out when to use each. So let's look at this triangle. Okay? So I have triangle ABC, and I have given you all the angles and all the sides. So let's fill out this table. Measure of angle A. 50 degrees. Now, on the calculator, it's asking you here to calculate the sine of each angle using a calculator. So in the calculator, you're going to do sine 50. What's sine 50? 0.77. Okay? So if you do sine 50, make sure that your calculator is in degree. It says DEG or D on the top, or not. The calculators are usually given to you in degrees unless you change it. All right. Now, the length of the opposite side. So we're going to write the length of each side. So if I'm looking at this triangle, where is the side of angle A? Which one is the opposite side of angle A? Which is what? What do we call that? BC. So this is named because this is angle A. The opposite side from angle A is called side A. So we always, when we have oblique triangles, so when we have triangles that are not right angle triangle, we always name the angle and its opposite side with the same letter. Okay? So if this is angle A, that means this is side A. We use big letters for angles. We use small letters for sides. We talked about that yesterday in the lesson. Now, let's continue just with this. Where's side B? A, C, right? Side B is this one. And this is side C. Okay? So what's the measure of side A? 26.4. Now, this is asking you for the following. It's asking you to find the ratio between A over sine A. So they want you to do A over sine A. What's side A? 26.4 over sine 50. So what does that give you? Yeah. 34.5. Now we need to do sine A over A. We'll talk about why are we doing this after, okay? So sine 50 over 26.4. So let's move to angle B. What's the measure of angle B? 65. And then if I do on the calculator sine 65, what do I get? 0.59. Oh, 0.9. Okay. What's the measure of side B?
31.92.
Now on the calculator, you're going to do B over sine B. So 31.2 divided by sine 65. What do you get? 34.4 what?
25.
Okay, so 34.4. Let's see. And then you need to do sine B over B. What do you get? 6? And just get it. I got 0.029. And then for this one, $0.29. Okay, so be careful when you're doing this in the calculator. What happens when you put sine, the calculator opens a bracket for you. So if you do sine 50 over 26.4, without closing this bracket, the calculator is going to do the 50 divided by 26.4 first, then it's going to do the sine. So make sure that when you put sine 50 divided by 26.4 to close the bracket.
After the 50.
After the 50. Okay. Angle C, what was the measurement of it? The sine 65 is 0.91. Side C was 31.2. When I do 31.2 over sine 65, and when I do sine 65 over 31.2, I'm going to get 0.029. All right. So let's look at all of these answers. Let's look at this. What can you tell me about the answers for this? Well, if I didn't round this, right, it was 34.45, right? So it was actually 34.4, right? And this is 34.4 and this is 34.4. So what do we notice about these ratios? What do we notice about these? They're the same. How about when I did sine A over A and sine B over B and sine C over C? What was my answer? They're all the same. Do you think that's a coincidence? Is it only going to happen for this triangle? This will happen for every single triangle that's an oblique triangle. Okay? So what this says that when I do the side and I divide it by the sine of the angle, it's going to equal to side B over sine angle B, right? A over sine A is going to equal to B over sine B. It's also going to equal to C over sine C. This is always going to be the case. Now, with respect to the other one, it's the same thing. So you have the other formula was sine A over A is equal to sine B over B and is equal to sine C over C. And I can see that from my ratios that I just got. Do you guys see that? So these are two formulas, two different formulas that we can use if I know three pieces of information, I can find the fourth one. Okay? So let's look at the lesson. So it's called the trigonometry, okay, the sine. So that's why it's called the sine law. Right? So you have sine A over A is equal to sine B over B is equal to sine C over C. This kind of formula, we use it when we're finding the angles. So you see that the angle is on the top. The other formula, which is the A over sine A, the B over sine B, the C over sine C, we use that when we are looking for a side. Okay? So this formula is when we're looking for an angle. This formula is when we're looking for a side. Okay? Now, here's the scenario. You can find the side when two angles and any side are given. So, if I have this angle and this angle, for example, okay, if they give me angle A and angle C, and any side, doesn't matter which side, I can use the sine law. Okay? If they give me, pick a side. Which side do you want me to give you here? Which side do you want me to give you? A. So if I give you side A, right? You know angle A and side A. You know angle C. You can find side C. We'll look at examples. It will make sense with the examples. But because you know side A and you know angle A, so you know side A, you know angle A, you know side angle C, right? And you're looking for side C. So in this case, you're going to use these two. Because these two are known, this is known, I'm looking for this. You always need three pieces of information. Okay? You either need two angles and any side, you can solve for another side, or if you're solving for an angle, you need two sides and an opposite angle. This is very important. Right here, that's very important. Okay? So for this case, if I give you two sides, so if I give you side A and I give you side C, okay, I give you these two sides, I must give you either angle C, because that's an opposite angle, or angle A. Okay? So let's say if I give you angle A, then you can look for angle C. Okay? So, if I give you two sides, I must give you one of the opposite angles to this side. Otherwise, you can't use the sine law. Okay? Now, when you're using one of these formulas, you're going to have to use only two of the ratios. So in this case, for example, I'm going to use A and C, right? Because I know A and I'm looking for C. So I only use A and C. I don't need to use the B. Okay? You only use two of the ratios. If I give you A and B, you use only the A and the B. If I give you B and C, you only use the B and C. So you only use two of the ratios. Okay? Let's see how to solve. When you look at examples, it will make more sense. So I have this triangle, ABC. The first thing you always want to do is you want to name your sides. Okay? What do we call this side? There's no hypotenuse in oblique triangles. Hypotenuse will only be with right angle triangles. Okay? This is side A because it is opposite to angle A. Okay? What do we call this side? And then this is side C, right? It's opposite from angle C. Now, what do I know?
You know your angles, two angles on one side.
I know two angles and any side, right?
Yeah.
So that's good, right? So this goes back to this scenario, okay? I know two angles and a side. Do I know an opposite side? I know the opposite side of angle B, right? I know side B. Good. Now, I know B and angle B. I know angle C. I'm looking for side C. So, I'm looking for a side. Which formula do I use?
Looking for a side, you use A over sine.
So I'm going to have to use this formula because I'm looking for a side. Okay? Which ratios do I use? If I'm looking for C and I know B, which one do I use? I'm looking for C. I know B. C and B. So I use these two. Okay? So, here it is. B over sine B equal to C over sine C. Let's plug in the information. What's side B?
So it'd be 32 centimeters.
Over sine of what angle? Equals, what's side C? Do I know side C? I don't know what side C is. What's angle C? Okay. Eyes on the board for a second. I know 1, 2, 3 information. I'm looking for the fourth. Right? If you don't know 3, you can't solve. You need to know 3 in order for you to be able to solve for the fourth. Okay? Now, here's what you need to do. Eyes on the board. I'm solving for side C. How do I solve for side C? So, I need to remove that sine 40 from here from the bottom. And I can do that by cross multiplying. But instead of doing the actual cross, where I multiply the sine 60 by C, I'm just going to do half cross multiply. Okay? I'm just going to move that division of sine 40 over to the other side and becomes a multiplication. Okay? So I call this half cross multiply. Okay? Because I'm only cross multiplying one side. Okay? So that becomes 32 times sine 40 divided by sine 60. Okay? So that would be 32 times sine 40 over sine 60.
Do you have to put it in brackets and calculator? Or you just type it in just like that?
When the sine 40 opens, so you can do like literally on the calculator, you can do 32 times sine 40. If it opens a bracket, then you close it, divided by sine 60. Because it's multiplication, you don't have to put it.
And then close the bracket again.
Yeah, if it opens a bracket, close it.
23.75.
7.5 what?
751.
Okay. So, sides, in the lesson yesterday, did I say what the sides has to be? To how many decimal places? 1. I'm looking for a side. That means I need 1 decimal place. So what would it be? 23.8. And then the unit is centimeter. Okay, here's another example. Guys, the names can be anything and you can change your formula to any letters, right? If it says A over sine A, B over sine B, C over sine C, if I give you a triangle with like element L, M, N, then you can change them to M over sine M, N over sine N, L over sine L. So you can change your letters as long as they're corresponding letters. So I have this triangle here, X, Y, Z. I know that angle X is 83. This is, I'm giving you that. Angle Y is 35. And I know side Z is 26. Just get a piece of paper, draw this. Whatever you. The question is, I need you to solve for side X. Now, looking at that scenario, what do I have?
You have 2 sides and 1 line.
I don't have 2 sides.
Or
2 angles and 1 side. So 2 angles and 1 side, that means I can use sine law. Because sine law says you can use 2 angles. When you have 2 angles in any side, you can use it. So I'm looking for side X. Let's name the triangle first. This side what?
X.
And I'm looking for that. This side what? Z. And then this side y. Now, in order for me to find side x, I need angle x. Otherwise, I can't use it. I can't find it. Because remember that when I have the ratios, right? I have, let's say, a over sine a. I need to know either side a or angle a, right? But in this case, I'm looking for angle x. So I have, sorry, I'm looking for side x, so I have angle x. Do I have side y? Okay, so can I use angle y? No. I have side z. Do I know angle z?
You could.
What is angle z?
62. It doesn't even have to add up to 180.
That's right. So it's easy to find angle z. The first thing you have to do in this case is you need to solve for angle z. Because the sum of all three angles inside my triangle is equal to 180, right? So 180 minus 83 minus 35, what does that give me? So that's angle z, okay? So angle z is equal to 62. Perfect. So now, I have an angle on its opposite side, and I have this angle. I'm looking for its opposite side. That's what I need. I need an angle on its opposite side, which now I have, and I'm looking for this side of angle x. So, what would I use? So what would the formula be that you want to use? I'm looking for a side.
Oh, we'd use A over sine Z.
I don't have letters A and B and C here, so how would I change that?
Z over sine Z.
So Z over sine Z equal to
Equals
over
sine X.
sine x. So you see how you can use any letters as long as the letters are corresponding letters. All right. Do I know side Z? It's 26. What's angle Z? 62. Right? Equal to, do I know side x? What's angle x? I know three pieces of information. I'm looking for the fourth. Half cross multiply. What do you get? What do we have? 29.2. So, important part is you need an angle on its opposite side. If you don't have an angle on its opposite side, then you can't use the sine law. Okay? So our first step here was to find that angle. So I have the angle on its opposite side. Okay? So if you know already two angles, it's easy to find a third one. Remember that step because a lot of people get stuck there. They forget that the sum of the three angles inside a triangle equal to 180. And they forget that if I already have two, I can find a third. Okay? So it's important that I have an angle on its opposite side. And then what I can do is I have the other angle and I'm looking for the opposite side. Okay? Are we okay with this? Okay, that's another example here. So I have triangle ABC. Let's name the sides. This is side.
B,
This is side
C,
C. What do I know here?
Two sides.
Two sides
And
and
opposite angle.
an opposite angle, right? So two sides, but it has to be an opposite angle. So I know two sides and an opposite angle. What am I looking for?
angle,
Angle what?
angle C.
Angle C. So I'm looking for this angle. Because I'm looking for an angle, what formula do I use?
Sine, or A over sine A.
So I have to use the sine A over A, right? I have to use this formula. Now, which ratios do I use? The A, B, C, which one do I use? B and C, right? Because I know B and I'm looking for C. So, sine B over B equal to sine C over C. Are we okay with that? Let's fill out the information. So that will be sine 60 over 50 equal to sine, I don't know what, over 30. Okay, what do you do now? Half cross multiply. So you're multiplying the 35 by sine 60. I always recommend that you put the number in front of the sign, just because then you don't have to put too many brackets. So I usually go 35 times sine 60 over 50. Okay, so again I did half cross multiply. So what does that give you? What does that give you?
I think 60 degrees.
So did you do 35 times sine 60 over 50? What did that give you? What's the answer?
Sine 60.
So 35 times sine 60 over 50. What does that give you? 0.6. What's after the 6? Is that angle C? That's sine C. How can I find angle C?
No idea, that's why it's like off.
Anytime you're finding an angle, what do you have to do?
Shoot.
The inverse. The inverse. So you have to do the shift. Okay? So anytime, eyes on the board, this is very important. Because a lot of people think that when I get this answer, I'll just multiply by 100 and get, no. We don't do that. Okay? To find angle C, you have to do the sine inverse. Okay? So anytime you're finding an angle, you're going to have to do the inverse.
I was right.
You have to do the inverse option. Okay? So in this case, sine inverse of 0.6062. That would give you angle C. So on the calculator, you're going to do either the second button or the shift button. And then you're going to press sine. And that is going to give you 37 degrees. Now, yesterday in the lesson, it tells you that angles should only be 2 the nearest angle, no decimal.
What did it say for 4 decimal places?
So you see how I did, like when I did this, right? It was 4 decimal place.
Oh, okay.
Okay? Because when I do the sine inverse, that's the closest I can get.